Alright, for this very first video for section 0.2, what we're really just going to go over are those first 6 definitions on your handout. And the main thing that we start with is our real number line. Okay, you can see I'm focused in on that. I have it written on the top left part of the page. We have, let's see here, this is also known as the origin, 0. Then if we go to the right, we have all positive numbers, 1, 2, and 3. If I go to the left of the origin, I have all the negative numbers, -1, -2, -3. Okay, this arrow here means that you go to positive infinity. This arrow here means it never stops. It goes all the way to negative infinity. Everything that's in between these whole numbers, and we like dealing with whole numbers, are all fractions. You know, if I had this, I could say this is 1/2, which is a decimal, is also 0.5. Okay, any number, whether it's a negative whole number, 0, a positive whole number, or a fraction or a decimal, it's on the real number line. And you can see that's your first definition. So real numbers is basically it's any type of number. Any number on the real number line. Real easy. Then from that you can kind of see how definitions 2, 4, 5, and 6 are on the left column, and kind of 3 is on its own. The reason is real numbers are broken down into 2 different types of categories, or 2 different types of subsets, you could say. If you have a real number is either a rational number, which is number 2, or an irrational number. So let's move down to these definitions. Okay. Alright, so we'll just focus on rational number here. So number 2, a rational number, this is any number that can be written as a ratio. Now another name for ratio is a fraction. So I'll put also fraction. Some examples, let's put some examples. Sorry, I'm just having a hard time writing here. Some examples right here, move this up, we could say, well, the one example we had was, what, 1/2? Right, that's a fraction. 1/3. I'm also going to put a whole number in here, 3. Now, 3 might not look like it's a fraction, but you can write 3, or any whole number, and put it over 1. So there's a ratio, or a fraction, 3/1. So that's a rational number right there. Now, an irrational number, if I move this over, it's just the opposite. Now, you can see I have this on its own, and I have it in a different color. So an irrational number is any number that cannot be written as a ratio or a fraction. The most famous example is pi. Right, I'll put the symbol for pi. Now, pi, we know we round it to 3.14, but that's when it's rounded, but it actually goes forever. I don't even know what it is, like 5, 6, 7, 9, and it keeps going. Well, irrational kind of means that there's no reason for it. It doesn't make sense. This goes on forever, and there's no pattern to it. 0.145679, there's no pattern to it, so it kind of doesn't make sense. Most numbers that you deal with, most real numbers that you deal with are rational. Every now and then you'll have some irrational numbers. And we'll take a look at some other examples of this in class. Okay, then the last couple definitions, so if I move over, alright, if you look at 4, 5, and 6, I have them all written in red, and they're underneath rational numbers. So natural numbers, whole numbers, and integers, these are subsets of rational numbers. Okay, so natural numbers, these are just positive whole numbers. These definitions are real straightforward. So positive whole numbers, well, that's easy. I'm just dealing with 1, 2, 3, 4, 5, 6, 7, 8, 9, and I keep going to positive infinity. Another name for natural numbers, you guys can also write this down. Sometimes you'll see certain textbooks, they won't say natural, they'll say counting numbers. I actually kind of like that better, because if you count, you always start with 1. You don't count and start with 0. Okay, whole numbers, it's almost the same exact thing, except you just add 0 in it. So it's just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you keep going all the way to positive infinity. Okay, integers, you just add negative whole numbers into it. So we're going to kind of go both ways, to positive infinity and negative infinity. I'm going to put dots each way. I'm going to put, let's see here, -3, -2, -1. Okay, that includes 0, and then I have the positive whole numbers, 1, 2, 3, 4, 5, and it keeps going. So you can see as I went down these, Okay, so you can see as I did natural numbers, whole numbers, and integers, I only dealt with whole numbers. I didn't deal with any fractions or decimals, but you really have to know the little differences between them. So kind of a way to sum it up right here, kind of a big picture, okay? A real number, there's two types of real numbers. It's kind of like this is like a little, they kind of branch off. A real number is a rational number or an irrational number. And then if it's a rational number, these branch off to these. It could be a natural number, a whole number, or an integer. Good thing about an irrational number is an irrational number. There's no subsets of an irrational number. All right? So we'll deal with more of this tomorrow and kind of going over some other examples of these number sets.